accessories for our stand where you have an adjustment here to X. Nice high leveling tables that give us precise, fine adjustment to move and measure on, really hard to measure and reach places. So that's the big difference between skidless sensor design. The skid, the big advantages there are what Tony mentioned. It's more stable because of that large force being applied to the skid during measurement. More stable in the environment you're in. It's the most economical system and compact. But anytime you reach a limitation on the skid type, one of the available styli can't get you to where you need to measure and you want to. Another thing we haven't talked about yet is the skid type can only measure a flat surface or a linear measure on a radius or anything that's not linear. The skid mechanically stops you from being able to do that, and available overall contour and do an appropriate roughness analysis, where that's another advantage of only the diamond contact. It can actually contour. So if surface roughness along a radius, you make contact, fire those data points, the processor has the appropriate calibration to remove the overall radius and then apply and give us our roughness profile, roughness results. So the only limitations skidless type units are they are a more expensive unit. Type. I wanted to take this and incorporate it into a fixture to place it somewhere and measure. It's a much larger drive unit. It's a little harder to get into things and things of that nature. The skid type is more conducive to measuring things where you have some of those issues of acceleration and movement in the environment. And I'd like to mention skid type is our entry-level units. There are two available. SJ210 has a larger display with a built-in printer. If you'd like to print out with the part as it goes down the line. The SJ410 series that I'm standing behind here is our first system that has this skid sensor. But this sensor is, as we go, the next SJ product we have is this one over here called the 500. Same sensor, exact same styli as the skidless unit. Different design in the, and really the big that you can get with a evaluation software. Look at something like this. If some more data you don't, you're able to take a look at that data that's acquired and use software-based tools to extract the sections that you'd like to analyze. There are also some benefits to reporting and data collection that you can do on a software-based system that you can't so much on a microprocessor-based system. So, this is just the beginning of the skidless units, the SJ410. We also have an SJ500, and this sensor is also included on very high-level systems. Automated columns, automated Y and rotary tables. So we just take the sensor, and as we go up the line, we go to a software-based solution. Then it's just degrees of surface texture measuring. Next, stylus on all of the up. I'd like to remind everyone, if you have any questions, please go ahead and post those. And at the discussion, we're answer anything that you'd like to know. On our website, we have documents not only about our specific products, but there's a really great resource on our website called the Quick Guide to Measurement. There's a whole science and nomenclature to surface roughness testing. There's filters, parameters, profiles. It's its own science to itself. And if you haven't been educated on it, it can be a little overwhelming. Well, we have some nice resources that explain the basics just surface roughness callouts and filters and all those things. Should I use a 2-micron diamond, a 5-micron diamond? We have some great resources that, and at any time you can your local Mitutoyo representative, and there are application engineers like Tony here in all of our showrooms throughout. I'd be happy to sit down, take a look towards the right piece of equipment. And so now I'd like to hand it to Tony, and I'd like to see how you use a skid type system.
We'll do. And as Tony said, just a reminder, we're passing this in 3 different venues. Please just give us comments and likes. We want to see just any questions about this session. Also mention about this SJ310 and the SJ210. What's the two units? It's pretty simple. It's only the display. Both are completely the same, except this one includes a printer display. Both are technically the same. Now you will say, but they look too different. How come they are the same? Well, the only reason is I'm using a right here that you can also buy here at Mitutoyo. And in this case, I'm using an extension. A lot of people don't realize set an extension cord and measure away from the unit. So let's I'm gonna show a couple things. See me a close-up of this image right here. I have right here, as I mentioned, here is SJ210 included with the extension cord. So this will give me an extension to measure bigger part, or if something requires a little more length. So very simple. The only thing you do, you set it up where you need to. And easy as that, you simply press. And currently the status is moving, and trace the surface and conditions. That depends on the drawing you're working on. So easy as that. We got a 20 micron inch surface finish. I like when work. One more thing, round surfaces with well, yes, but big disclaimer, you can only measure surfaces only one way. You can measure them parallel to the axis of cylinder figure you're trying to measure. You will not be able to measure them this way. And the reason why, as I explained, is that there's limited ZX range. Round surfaces is parallel to the axis of the round surface. So measurement right here. Perfect. If you notice, there's gonna be some people trying to, but you will not get results. And even if you get results by measuring perpendicular to the axis of the cylinder, you will not get reliable results because this is not correct. The only way that you can do this, as Tony mentioned at one point, it has to be a linear. If you measure parallel this, I'm just gonna press start. Then this way is gonna be a linear movement, making a trace. You will not run out of range. Very simple, didn't do nothing. So add any of our additional accessories. So it's done. It includes a printer. So let's just say we want a printer. Label right here includes surface parameters, includes the graph, the result, a title. You can here sometimes you wanna get a receipt like this. Close up shot right here. There we go. Thank you. All the information that I will show values for those engineers out there. Raw data. You can get all your mathematical formula, peaks, and this graph. and the result right here. So really simple. You can adjust any here. So great, great potential with the skidded systems. So Tony, why don't you show us maybe how do you use the skidless systems to measure?
Thanks, Tony. I really like the unit. Something that most facilities are a height gauge, right? We have this nice adapter. We can take this small, compact, and it's very flexible, as you just showed, easy to position and take a measurement on your part.
Very easy.
You know, one of the benefits of the skidless type is to restrict it. And now we can't drive unit and put it on a height gauge; it's heavy. But we do have this column stand that not only has the ability to move it up. Of this gives this system a little ability, since we here low force. You could zoom in here on I have a part up that has a fairly narrow groove. Now, just why this is, let's come all the way in, please. A groove here. Let's say we wanted to measure the floor of that groove. Bring into picture the skid type. It restricts me from even placing this in the groove. Even if I could, there's no room left over to take a measurement. One of the limitations of the skidded, where here I have a skidless type, I am able to bring my column stand down, get close to that area. If I need to move left, we have these great optional accessories like this XY table. I can fine adjust, move the part left and right. I can measuring position, move it. And there. This piece is able to get into the groove and leave enough space to actually take a measurement. This SJ410 maximizes our ability to measure in small areas. So now I'm situated there in the groove, zoomed in, but I'm pushing start on the processor here, and I have to exit that menu and hit start, and that's pulling slowly across the surface. We got our one cutoff of inch of measurement there, and the system's able to put that information. And so if you could zoom back out, please. There we go. So that's one example of the small in and out. But we look measuring in a corner on a is really difficult. That's great where we have this corner type stylus. We can really maximize, place it right in the corner, and get all the distance that's available. We have the main unit here, as we discussed, some optional accessories. As you see, the stand makes it very easy to locate on small features. Having a table gives you the flexibility to censor things, move in the X position exactly on the place that you want to measure. We have some other accessories available that X-axis adjustment if you want to move the system, and a leveling adjustment is a secondary optional accessory, and full did for really high use applications. So me moving this column up and down. As the operator on this system, you need to position and bring it down with the amount of force to measure in the range. Sometimes quickly can be damaged. We do have a accessory here called an auto. What that gives us the ability to automate the position and the contact with the part, as well as after the measurement coming up before it runs. So if you have an application where this is being used a lot for the same measurement by many different positioning, will really protect your equipment be, if you had a fixture, operator could load the part, hit start, the unit, the auto set unit here would bring it down into the making contact, take the measurement, and it has the ability to bring it back up. As now the operator can take that piece out, put the next piece in, and just hit running. You get more and more automation where all or most of that can be automated. So that's a quick demonstration of skidless versus skidded. They're both great units, but they do have their benefits and their drawbacks. I'd like to open it up to the questions that we got during this event.
Don't forget, please like and subscribe.
Yeah. So Tony, we have how do we perform calibration on any of these profiles testers?
The setups or different ways to do it from skidded to skidless. Right. The only thing you need is specimen, surface roughness specimen. This is very simple. This is all it gets when you buy skidded or have to do is bring it down. I don't have it right here, but the only thing you have to do is set it where you need to set it, bring it down, just press start. Actually, is go to the menu and go to the calibrations and just change standard. That's all because both units come with a setting that will automatically give you the right setting. So press start, our calibrate.
As Tony mentioned, precision roughness specimen is a single one of our programs. And this is a real, it takes about 30 seconds, I would
Pretty
say,
much,
maximum. Yep. As Tony mentioned, whatever stylus you're using with skidless or detector and stylus you're using here, every time you make a change, you can make contact, hit run. What it does is it takes this known value from the specimen, approximately 120 microinch RA, and it takes a phenomenal and creates a gain adjustment value. So you're, regardless or which stylus or detector you're using.
Simple as that.
Do we have another question?
Alex, do you have another question?
Yes. Can you transfer data to a computer?
Oh.
If you don't mind.
Please do so.
Just take your measurement data however you would like. So we saw a very straightforward method on the 310 or 410, 500 built-in printer. So if we want our results, our settings, our graph, we can tailor it to whatever we'd like and actually have a small, receipt type printout that the part through your facility. But in this day and age, we want other methods to collect data. All of these units have multiple output ports on the back of the processor. Digimatic, RS-232, SD card slots.
Yes.
So there's different digital ways to get data out of here. Mitutoyo makes a wireless data transmitter. We could put on here, hit send, and that result. But a really nice benefit of these SJ systems is something that we offer called the SJ communication utility. What is that? That's utility software that's available on our website. If you go there, you can download that. And that gives us the ability to do one of two things. Either directly connect any of these systems with a USB cable to a PC that has this utility and Microsoft Excel. It develops a looking certificate in a meeting, a little bit better than.
Wow.
And all you need is a USB cable, or the other option you have if you're not near the computer during measurement, you can put an SD card in one of these systems. Measurements, save them to the SD card. Go to that has the freeware, put the SD card in, and evaluate the stored results. So yeah, definitely ways to get the data from this system, either a paper printout or USB communication. A lot of different.
Free. I like free.
Yeah, that's
I like
great.
free.
Yeah, I like free too.
Here's another question. Let me take this one, the next one.
Sure.
Are all styli compatible between the units? No. Compatible only with skidded systems. The styli for skidded systems are compatible in between these two units. If you are running out of range or you don't have much space and you're looking at our brochure and say, well, here's one that looks slimmer. Those perhaps belong to skidless systems. So they're not compatible. Skidded and skidless systems do not have compatible styli.
Yeah, it would be nice, but I've received that question many times, Tony. One of our end users, of what they can really like to take use it with that, but unfortunately, skid type sensors only available to use with skidded, styli only available to use with the skidless system. We have another question, very detailed, that we didn't touch on.
Why don't you take that one, Tony?
Can either of these units check waviness? So at the beginning I said every component of a surface is surface texture, but there are different components in. Are the